Here we get some nice fun stuff. This is why I wanted y'all to do your tri-sigma. This is the only one that I offer my students with a horizontal load. We do have to calculate our vertical here using some Pythagorean theorem. And we calculate our vertical, 20 to 10, I don't remember what that calculates to. But that's how you calculate that. You don't have to get weird with this. It's literally 30 times this height. It's not 30 times this distance. Because if you go from A directly to E, this is no longer perpendicular to that. So you would have to do some weird calculation to figure out the angle from A to E, and then calculate the component of 30 over to that weird angle, and then you multiply that component force times the distance from A to E, and you get the exact same number as 30 times this height. You get the exact same number and in the exact same direction. Is that clockwise or counterclockwise? From A to E.
Well, it's clockwise.
It's clockwise.
Clockwise.
And as a result of it being clockwise, is this negative or is this positive? In moment.
Negative.
Negative.
It's negative moment. So, yeah, it's tricky because it looks like it's positive. It's positive in x, negative in moment. So that is a little bit weird, but it is what it is. Forever and ever, amen. Truss F, nice and simple, just a lot of loads. Gets a little bit weird. This is where we basically respond to making sure that we've got some examples that have some stresses in these vertical members. Just to freak the kids out because they may get used to saying, oh, well, these are nothing, these are zeros. Nope. However, CK and EI, those are going to have zero. Because, again, at K there's nothing, so CK can't have anything either. At I there's nothing, so EI can't have anything either. But that doesn't mean that C and E are going to have nothing. They don't have any external, but internally you're going to have some weird stuff in CL and CJ and EJ and EH. You're going to have some weird stuff going on in there. Make sure you pay attention to your directions, and you won't have this weird compounding stuff that I warned you about earlier. Finally, this is the thing that I grabbed it. Making sure that we relate this back to PLTW so I don't get kicked out. So that Emily can report back to the mothership and say, nah, he's all right, you can keep him. This is all about 124. No, not 124. Sorry, 2.1.4 and 2.1.8. It's a typo. My apologies. I will fix that before sending it to upload. That's cool. That's why I like it. 2.1.4 through 2.1.8. 2.1.4 is all about vectors. 2.1.5 is about forces. 2.1.6 is about simple trusses. 2.1.7 and 2.1.8 are about building physical trusses and breaking them.
Mm-hmm.
I absolutely, again, I cannot stress this enough. Get the SSA. Get the SSA 1000. You can do this using the Vernier software, Lab Pro. You can, Vernier sells a stress apparatus that you can tie in. It kind of looks like it's Vex parts, it's these aluminum pieces. You can do it with that. Not nearly as cool as the SSA 1000. More importantly, it's not nearly as versatile. The SSA 1000 is robust and it's designed for this. We've had ours for 10 years. AMT, Advanced Materials Technology. Their help. This dude literally gave me his personal cell phone number. We had a problem with the chip in our machine. The chip freaked out on us. He literally shipped me overnight for free a replacement chip and told me step by step how to open up the machine and replace the chip. So instead of shipping the machine out and getting it back, he was like, nah, you sound like you know what you're doing here. Do this. The belt slipped off, called him on his cell phone, said, hey, I hear the motor going, but nothing's happening. He goes, this is what I think happened, pulled it back off, tell me what you see. And again, like in 20 minutes, I had the machine fixed because it was a simple fix and he was incredibly flexible. It's an investment. It's an absolutely worthwhile investment. It is not an optional piece of equipment, regardless of what the purchase manual says.
I have it, but I've only used a composite material.
Cool.
It doesn't crush the balsa wood, but when you crush the rubber.
Did you send that cleaning pop-up on me?
Which one are you talking about?
The SSA 1000, because like everything, all the plates on it are super heavy. They're putting like little balsa trusses in it, so if I put them.
Oh, so you actually make a special rig
A holder for it?
for this activity? Yeah. Jump ahead and look at the activity. There's a rig that you have to build. They used to, I think you can purchase one.
Plastic thing, I think.
That's, yeah.
Okay.
There's a plexiglass one that works pretty well. There's also one that you can make out of Vex parts. The Vex one is kind of a pain in the butt. There are also, I strongly suggest, and I don't think I have the parts on my computer here, but for the aerospace course, for the composite testing, we actually had to build all the abutments. And so there's basically a block that you sit on each of the abutments, and then a ring horseshoe, basically, and then you just stick a hole through it.
I get that little, release from that.
Yeah. Installations, everything's smaller anyway.
Yeah. That stuff you have to buy online.
Yeah.
But
you can
you
always,
can
you should be able
make
to
some
in
abutments,
your
because the issue that we were having was we didn't have enough travel,
Go to your mailbox
enough height
and
to
check
get to
your
travel space. Yeah.
junk.
So that's going to be your other solution there. And again, just 3D print them, and you're going to spend a ton of material because it's got to be a nearly full fill. So if you've got a U print,
Cool.
if you've got a U print, it's going to be fine either way. If you have like an up box or I don't know what that means.
Yeah, it's
That sounds like, isn't that like the bad guy in Doctor Who?
it is.
Okay.
It works fine. I've like pretty much redone every part of it.
Fair enough. So anyway, so applying to PLTW activities. Calculating force vectors. Everything on force vectors from the first section. You can certainly go with what's in the PLTW curriculum or supplement it with this. I kind of do both, where I say, I give them this first, and then I give them the PLTW curriculum portion of it, and I say, okay, now 2.1.4, have fun. 2.1, that's 2.1.5, my apologies. Calculating moments, applies to sigma m. We've already done this back when we were doing simple machines.
Right.
But you have to tell it. If you don't, you're going to get one kid that's going to be like, oh, dude, this is like levers, man. And you're like, yes, this is exactly like levers. And literally the rest of the class is like, what? No, it's not. I'm like, no, oh my God, yes, it actually is. It's
That's true. That's very
It's
true.
totally the same thing. Yeah, it's a weird day. 1.2.6, the step-by-step Truss system. The activity that's in the curriculum is not intuitive. I have yet to find a student or adult to look at that activity and say, oh yeah, no, this makes sense. So I absolutely take them through this first. My method of joints first. Spend a couple days on this. And then I assign 1.2.6, stressing that we're now making it more complicated. We're getting into some, because in the examples, the angles are no longer 60 degrees, so you're no longer able to just kind of memorize from your unit circle and, use just 60, 60, 60, 60, 60. Now you have to actually think about what's going to happen if I add this to 180 or subtract it from 360. So you do have to get a little more complicated with that, but it still works. It is a different approach. It is not wrong. Some of your kids are like, no, it's a different way of approaching it. It's a different way of looking at it. I require them to continue using the table as they go through it. That's me. It's a different approach. That's fine. Finally, calculate. Oh, that's right. That's what this is. This is a really fun one. The calculating truss forces activity, 1.2.7. I love it because now we get away from looking just at these simple truss bridges, and we start looking at these weird kind of, like this is like, all right, this is what a sign would be. But again, we have a situation where we've got a pin, we've got a roller. This roller, what direction is that roller applying its force in?
Y.
X.
Oh, it comes in now.
This is allowing rolling up and down, so its force is actually in X, left and right in X. So this is trying to induce what direction of moment? Positive or negative moment?
Positive. Negative, I'm sorry. It's
Negative moment, because this is pulling down relative, it's down in Y to the right of our pin, so this is going to go clockwise. Same analysis here, except here we have our pin on the right. All of our moments backward now. Exactly.
So now it's going counterclockwise.
So these negative 500 in Y, negative 500 in Y, these are positive in moment. That's going to freak your kids out. You get to choose, because you know your kids. Do you want to freak them out, or do you want to flip that over? I like letting them freak out for a couple minutes. Makes me happy. And then about maybe 15, 20 minutes into class, I show them how to draw this back. One or two of your kids at least aren't going to draw it backwards automatically, because they're going to remember from a week ago, oh, dude, do it this way. And they're going to be fine. And the cool thing is that takes this and puts it in this same position, which means that positive X, positive Y, blah, 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 etc. You get the idea. So, the peasants rejoice. Finally, we get to the truss design. Once again, doing in the SSA 1000 is a little bit weird. Buy it, buy it, buy it. Get it. Get the damn thing. Just find a way to get the money. Find a way to get the thing. Perkins grants are the way to go because they're here for STEM. Buy expensive STEM stuff. The only thing about Perkins grants, you have to be careful about where you put the machine. You have to be careful about where you transport it. You cannot share it with another building. It has to, literally you have to register what room it's in. So technically speaking, we have to be careful about wheeling it from one room to the next. We don't really panic about that. I'm just gonna be honest. But in terms of taking it from, if you've got a multi-school campus, that's itchy, but certainly a situation if you've got another school in your district that is running a Project Lead the Way program, they're going to need their own. Do a Perkins grant for your wind tunnel as well, the jet skiing 500. That's not an option. There's nothing else on the market that's going to replace that. Like nothing. Dude, it's so awesome. On back to school night, run that thing at 80 miles an hour.
Nice.
Yeah, you see Dorothy whipping down the hallway. And the kids sign up, which makes it even better. Here's the thing though, with that project, go big. It's gonna recommend a couple of different options. A lot of you probably have a whole lot of this 3/32 basswood or 1/8 inch balsa wood, the really thin square balsa wood. Don't do that. Go up, go to 1/4 inch and go basswood. It's a little bit more expensive, but the reason you want to do that is it's stronger. It is statistically significantly stronger. And by going with 1/4 inch, you're also going to add to that strength. And you could certainly do the rectangular stuff that's, you know, quarter by eighth, or you could do quarter by quarter, which is it's a little bit ridiculous there, because then it gets really hard to cut. The quarter by eighth is certainly fine. The reason you want to do that is the SSA 1000 doesn't register that a test has begun until you hit 10 pounds. Because once you hit 10 pounds, it starts to measure deflection. So it doesn't want to start measuring deflection if the test hasn't begun yet. Because then it's measuring, because you could start the plate up here, and it doesn't, this isn't deflection. It's not deflection until it actually starts bending your, whatever you're testing, or pulling on whatever you're testing. Because from this, you can actually, from the force deflection graph that it gives you, you can actually calculate a stress strain. Quick Excel stuff in your group. But you need, if you're using 1/8 inch balsa, you may not hit 10 pounds. And if you don't hit 10 pounds, you don't have a test. You're just assuming stuff. Whereas go with the bigger stuff, with the basswood, you get up into the higher stresses, you get into the higher force loads, and you're able to actually get some comparisons between, you know, yours and yours and yours, and it's absolutely worthwhile. It's a good choice. That means that you may need to call your department chair, like send that email tonight and say, yo, we need to jump on this and get some wood in, if you don't already have that on your wood pile in the back room. Alternatively, you can always make 1/4 inch by 1/8 inch balsa by taking 2 1/8 inch by 1/8 inch pieces of balsa and laminating them. Take them together, put a lot of glue together.
Basswood, is that something in the store, or is that something I can just pick up at Home Depot? Or?
You may not be able to get these at Home Depot, but wherever you're buying your balsa, you're also going to buy you should also be able to buy basswood. Definitely a hobby shop should have both. Basswood is it's effectively the same stuff, it just has a tighter grain.
Okay.
Yeah, balsa is very low density,
Right.
basswood is low density. They're both whitewoods. If you take a 36 inch piece of balsa and you go like this, it's just going to shatter. If you take the basswood, you can actually whip it.
Wow.
If you kind of make your students, you can also have them very carefully measure out the full middle folders and put them together. And if you got a ton of middle folders,
That's true.
you can make trusses that are relatively strong.
Yeah, that's absolutely true. And so yeah, so whatever material that you have, you can do. For the SSA 1000, that's why I'm stressing going with the basswood, because you want to get to that 10 pound limit.
What if would like dowels? I've seen square dowels, you know, 1/2 inch square
Yeah.
dowels. Do they work pretty good? Or?
Yeah, I've never used them. I don't see why they wouldn't.
Yeah.
So whatever material you've got access to, you can make it work.
Okay.
Yeah. I've got a student this year, or rather my colleague has a student who in a different course, just for funsies, he's teaching himself Inventor, and so he's actually speccing his bridge in Inventor, and he wants us to 3D print it, and the hard part is going to be convincing my department chair to then allow us to put it in the SSA. I don't think my boss is going to be like, sure, let's go ahead and spend $40 building your bridge just to crush it. However, taking that and putting it in, if he follows through and makes like an engineering poster, and we put it in the display case, I think I could convince him. I think it could be cool. So yeah, Mr. Gasket, think about it. Think about the possibilities here. I'm recording. Okay. Yeah, cool. That's my show, folks.